Good afternoon. Today I would like to present our project, which is Academic Study Plan Management System. Our project is a web-based system designed to improve the current study plan process in the university. At the moment, the process is still manual, which means students may need to prepare their study plans manually and academic advisors need to check them one by one. This method can be slow, inconvenient, and may cause human error. Because of that, our system is proposed to make the process easier and more organized. The main purpose of this system is to allow students to create and submit their study plan online. Students can log into the system, view the list of available courses, and choose the course they want to take for the upcoming semester. The system provides a user-friendly interface so students can add or remove courses easily while preparing their study plan. After the student submit the study plan, the system will automatically perform eligibility and prerequisite checking. This means the system will compare the status courses with the study academic history in the university record database. If the student does not meet the prerequisite for a course, the system will stop the submission and show a message explaining the problem. If all requirements are met, the study plan will be marked as pending advisor review and sent to the academic advisor. For academic advisor, we prepare an advisor dashboard through advisor dashboard. Through this dashboard, advisor can see all submitted study plan, review them, and then approve, reject, or add comment. If the advisor approves the plan, the system will automatically update the student registration clearance status in the university database. The system will also send an email notification to inform the student about the result. Besides the functional feature, also includes several non-functional requirements. For example, the system should return validation result in less than 3 seconds, double auto save to prevent data loss, and protect data using TLS encryption. That's all for me. Thank you.
Now I will.
My name is Golden Xian. Now I'll present all the diagram of this of our system. First is concept diagram. Our context diagram shows the overall system architecture. To meet university requirement, our system does not create its own database or email service. Instead, it connects to 3 external systems: University SSO Portal for secure or user authentication, University Record Database to retrieve academic record and update student clearance status, and SMTP email server to send automated email notification. The 2 main users of the system are the student and the academic advisor. Next, on to the level 0 data flow diagram. The level 0 data flow diagram breaks the system into 5 main processes. Process 1, authenticate user, sends login credential to the SSO portal and grant access without storing password locally. Process 2, submit plan, retrieve course information for the course catalog D2 and store both some submitted plan and drafted plan in the study plan file D1. The draft flow support the 60-second autosave feature. Process 3, validate eligibility, automatically checks course prerequisite using the record from the external URD. Process 4, advisor review, record advisor decision in advisor review log D3 update D1 and send a modification request through the SMTP server. For process 5, update registration, update the student clearance status in the URD and send confirmation email through SMTP. For level 1 DFD, we can see how specific SIA requirements are implemented. Process 1, process 1.2 send credential directly to the SSO portal, ensuring passwords are never stored or processed by them. Process 2, process 2.2 checks that students select between 1 and 7 courses while process 2.4 continuously perform the 60-second autosave function. Process 3. Process 3.2 retrieve record from the URD, and process 3.3 check prerequisite eligibility before sending the plan to the advisor. Process 4.2 record advisor decision for auditing, while process 4.3 send rejection or modification notification through the SMTP server without contacting student directly. Our case diagram includes both functional and non-functional requirement. Besides the standard plan, submission and review function, it also includes autosave draft plan, toggle interface language between English and Bahasa Melayu. The SSO URD SMTP service are shown as secondary actor because our system depends on them to complete important tasks. Next activity diagram. The activity diagram uses 6 streamlines: student, system, university SSO portal, university record database, SMTP email server, academic and academic advisor. These streamlines show the complete journey of the study plan from submission to final approval. There are 3 important rules shown in this diagram. Safety autosave. While the student is creating a study plan, the system automatically saves the draft every 60 seconds. This ensures that no work is lost if the browser closes unexpectedly. Number 2, queue advisor review. After a study plan passes eligibility check, it is placed in a queue for academic advisor. The advisor will then review the plan at a later time, not immediately after submission. Before reviewing, the advisor must log in through the SSO portal. Number 3, control registration update. When the advisor makes a decision, the workflow split into 2 paths. If the plan is rejected, the system only updates the local status and send a modification request through the SMTP server. If the plan is approved, the system updates the student clearance status in the URD and send a confirmation email. This ensures that only approved study plans are recorded in the university official database. Next, class diagram. Our class diagrams serve as a blueprint for the system code. External services are represented by interface classes: SSO Authentication API, URD Gateway, SMTP Gateway. We also created a Notification Manager class to handle email notification. An abstract user profile superclass is used so that both student and advisor can share common features, such as language switching without repeating codes. Next, sequence diagram. The sequence diagram shows how the system class communicate over the time. We use all fragments to represent different possible outcomes instead of showing only the successful path. The first all fragment checks authentication. If the SSO returns false, access is denied immediately. The second all fragment handle the advisor's decision. If the plan is rejected, only the local database is updated and modification request is sent through the SMTP to the student. If the plan is approved, the system updates the external URD and sends a successful notification to the student. This demonstrates that all business rules and requirements are consistently implemented across the entire system and remain fully aligned with the SIS. That's all from me.
Okay, now I will explain the work breakdown structure, which is WBS. The WBS is used to divide the whole project into small and more manageable tasks. By using the WBS, the team can clearly understand the project scope, task arrangement, and the work that need to be complete. In our project, the main activity include the project planning, requirement engineering, system design, system improvement, system testing, and final document. Next, I will explain the bar chart. The bar chart shows the project schedule from the week 0 to week 14. Each bar represents one project activity, and the length of the bar shows the duration of that activity. This bar helps the teams to see when each task starts, when it ends, and which task can be carried out at the same time. After that, let's go to the activity network diagram. This diagram shows the dependency between project tasks. From the For the activity network diagram, we identify two critical paths. The both critical paths need to take 14 weeks. This means that if any task on the critical path is delayed, the overall project complete time may also be a delay. Now I will pass to the next member.
Thank you. Hello everyone, my name is Marika. Today I'm presenting our testing suite for the academic study plan management system. It covers functional, integration, and non-functional validation. Starting with the module 1, we validate student study plan submission. The test case integration 001 confirms our path and authenticated student successfully submits a valid pre-course claim containing ICWB 101 and BUGSY 1313 and CPM 202. And to safeguard the system logic, we use boundary value analysis, test case integration 002, test the lower boundary by trying to submit an empty plan, which the system blocks with an error. For the test case integration 003, test the upper boundary by attempting an 8-course submission successfully, triggering our maximum 7-course unit block. And for the test case integration 004, verify prerequisite validation engine. When a student without basic OOP attempts to add advanced software engineering, the system instantly helps halt the attempt and flags a warning. Lastly, for the integration test case integration 005, confirms hardware compatibility cross-platform testing on university desktops and mobile devices, proves the system execute tasks smoothly without high CPU or RAM overheat. And moving to the module 2, we focus on the advisor review workflow and database integration. Under test case function 001, when an advisor clicks approve on a pending plan, it clears cleanly from the active queue. Next, for the test case function 002, validates that this content has been synced in a real time with our database backend, verifying that a secure REST API payload pushes status updates within our strict 60-second limit. Alternatively, for the test case function 003, covers the rejection chart when an advisor rejects a plan and inputs feedback. The system saves the comments locally and immediately fires an automated notification via our SMTP server to keep the student informed. Finally, for the module 3, it assesses non-functional performance. For the PC NF001, validates latency, proving a standard 5-course submission, updates the UI in under 3 seconds. Next, for the test case NF002, it evaluates our recovery engine by simulating a sudden browser crash after 60 seconds or upon relogging, the system restores the student's unsafe data, unsafe state perfectly. For security, the CNF003 utilizes the traffic analyzer to confirm that all payload transfers encrypted using TLS 1.2 or higher. Lastly, server analytics under TCNF004 and TCNF005 confirm our high availability goals. Total monthly downtime remained well under 60 minutes, and the system proved fully operational at all times outside our scheduled 12 a.m. to 2 a.m. maintenance window. So in conclusion, our test suite verifies that the system is functionally secure, computationally efficient, and highly resilient under stress. Thank you.
Okay, now I will explain the testing technical. For suitable testing technical, we select the functional testing, boundary value analysis, equivalent party tuning, integration testing, and non-functional testing. These technical are suitable because they cover the main system function, input limit, valid and invalid input, external system connection, and quality requirements such as performance and security. Now, let's move to the cost estimation. For the cost estimation, we use the function point analysis and the basis COCO-MO module. The function point analysis is used to estimate the system size based on the requirement, while the basic COCO-MO is used to estimate the development effort, time, and the cost. Based on our estimation, the project will require about 15.3% month of effort and around 7 months of the development time. So the total estimation cost is 84150 ringgit, including the library cost and contingency. The cost estimation can give the team a larger budget for developing the purpose system. That's all for our team. Thank you.